In this tutorial you will learn to build a car driving game using Unity's physics system. We will download a 3D model of a car and add the necessary Unity components to it. Then we will add the scripting to make the car drive, jump and crash, just like a real car would do. In an earlier video I showed you how you can easily create a driving game by letting the car follow the shape of the terrain. But that doesn't add real physics, so you cannot use it for a game where you want to crash the car or have it jump. If you want a real car simulation, you can use paid assets or write your own physics code. But the cheapest and easiest option is to use Unity's own car physics system. The downside of that is that you need to know how to set it up properly. Otherwise you end up spending a lot of time trying things out. But this video is here to help you with just that, so that you can have your own game in no time. I've already set up a scene that we can use to demonstrate the car controller. It consists of terrain made by the terrain editor, an HDRP water surface, a city. That's actually just a model I downloaded from internet. And over here we have some obstacles that are just objects, cubes and cylinders made with Unity itself. And finally we have some models of cars over here. You can first you will need to find a model of a car that you want to use for your car driving game. You can find many models on the internet. Some car models are for free. There's only one thing that you need to watch out for. The car model needs to have separate wheels. If you take this car for example, it has two wheels in just one single mesh. And now we are not able to rotate the wheels independently, so they will rotate like this, but we want to rotate them separately to perform the steering. So in this case what I could do is just remove these tires and replace them with tires from another car like this one, who has separate wheels. So I could just move them to this car and make this this wheel a child of this model. But that's a lot of work, so for now we will not do that, and we will stick with a car that has already separate wheels. We will use this Daewoo Matiz model, and you can see over here that it has separate wheels that you can turn like this to show the steering, and also like this to show that the car is moving. So this model is complete. There's only one thing I want to add, is some lights on the rear and on the front, just to make the car look more nice. And also we will use the rear lights to indicate the braking if you are pressing the brakes. So let's first create a sphere and put it where the headlight should be. Something like this. And now I will assign a material to it. I've already created a material. It's HDRP lit shader is used. And the main important thing is that it uses emission inputs. It uses HDR color. That's high dynamic range colors, and we use a high intensity, and that will cause the material to shine even into different areas than the object itself. You can see that over here. If I decrease the intensity, you will see it's just an object like this, but with the increased value we can see that it's really shining, and that's that looks like a real light on a car. Let's make it a little bit less bright, and we will add to this sphere, let's call this light front left, and add to it a light. Let's first add a spotlight. So this light will shine in this direction, that's fine, but the intensity is not strong enough. Let's just increase that a bit. I'm not sure how much it should be, but this is obviously too much. Something like this is fine. And we can change the shape if you like, make it a bit broader or something. And the direction. Also the color of the light. Can make it a bit yellowish. Now personally I like to add a second light, but if you don't want to do that, it's fine. It gives you a bit more performance, but if you add a point light with some intensity, it gives you a bit more light in this area, just to have a better view at night for the car. You can see the difference over here, but it's just a personal thing that I prefer to have, so you can leave that out if you want. And then finally you can just copy this light, rotate it a little bit, and we have our front right light. And you can do a similar thing for the back lights, the rear lights, and but in that case we don't need the spotlight really to shine, but just the point light. I've already done that for another car, so I will just add that to this car. So we'll just copy this light from this other car and add it to the Daewoo. Okay, that's it. So now we have nice lighting on the car, and we will use the rear lights also for braking. So if you take a look at the material, it has a property exposure weight. We can change it to make the car lights look brighter, and we will use that to indicate the braking, and we will do that by script, but you will see that later. So for now the car is ready, and let's make this a bit more nice. What we need to do now is add to the root of the model a rigid body. And we'll set it mass to 1200. This represents the amount of kilograms of the car. So 1200, it's a realistic value for a car. And this will affect the physics. So if your car doesn't drive very well and the handling is not good, you can maybe change this value to see if that will help. What we will also add is a box collider, because we want the car to be able to collide with other objects. So we need to set the collider shape to match the body of the car. So this is the box collider. Note that the collider doesn't extend to all the way to the bottom over here, because there will also be colliders for the wheels, and they need to touch the ground and not the box collider of the body. So beware that the collider is not moving too low and it doesn't touch the ground. And the final object we will add to the root of the car model is the car script. Each car has a car script. It contains the properties of the car. It's different for every car, so we have individual scripts for every car. But there's only one car controller script. And this car controller script is assigned a car as soon as you are driving one of the cars. So you can drive any car that you like in this game, but it will use then only one of these car property scripts. And now we need to add some more elements over here. We need to add the wheel colliders. These are special colliders for Unity to simulate physics of cars. So let's first add an empty object, and let's call this wheel collider front left, and then we add the wheel collider objects. The mass is 20 kilograms. That seems about right for a wheel of a car. We can change these values, but for now we'll just copy this wheel collider item to create a front right wheel, a rear left wheel, and a rear right wheel. But now we need to put them in the right position. So if we enable gizmos again, you will see the shape of the collider. And so this is the rear right collider, so it should be on this side. We can move it into the proper position. You will also note that this collider is a little bit too big for this wheel. So we will need to make the radius a bit smaller. This seems about right. Let's put it a little bit lower so the car will be a bit higher up. And when you are in the right position, you can go to the second wheel. Let's first make all wheels now with a radius of 0.4 already. And for the for this wheel we can just copy the values of the Y and Z positions. This car just only has a different X position, this wheel. Okay, so that's it. And then the front wheels. Okay, now that we have the colliders in place, we need to refer to them in the car script. So the car controller script actually knows where to find them. And we also need to assign the wheel meshes, the whole wheel, so this inside and this outside part. We need to assign that to the car script as well. Let's lock it for now and go to that wheel mesh and add it over here. So yeah, so now they are all referred to properly. So what will happen when we run the game is that the wheel colliders will stick to the ground, and if you make a jump they will bounce a bit because they have suspension, and they also take care of the position of the wheel, but they don't draw the wheel itself. So that's a separate procedure that will draw this this wheel into the proper position. So the position of these wheels doesn't really matter. We can put them even here right now, and when we run the game they will be properly positioned somewhere over here according to the position of these colliders. So these positions are really important. We can also set smoke and create an engine sound and a driver, but for now that's not really necessary. We can already run the game and see what will happen. You can see that we can already drive around like this. And if you are not really happy with the position of the wheels, you can change the positions of the colliders. So maybe they stick too much out. You can move them a little bit back like this. So don't change this. It even doesn't work when you are running the game, because the meshes are positioned according to the collider positions. So you can change the properties of the car to make it accelerate faster and steer better, but you can see also that when we are pushing the brakes, the lights are working. Okay, I've tweaked some values to make the car drive better. First of all, the motor force, I made it a bit bigger. By the way, this is now also the default of the car script, so it should be fine if you add it like this. We also increased the spring force a little bit and the downforce coefficient. This is very important. It gives the car a bit of force down to keep it on the road, and it stabilizes the car a lot, so that helps to make the car stick to the ground more and have more control over the car. So you can increase this value even further if your car doesn't feel like you can handle it very clearly. So the steer speed is 200. That's fast enough for quick steering, but you can put it in even a higher value if you want to have better response on the steering. And for the wheel colliders, the default values are not entirely correct for good driving. I would increase the stiffness. It's default on 1. The forward stiffness increased to 4, and the sideward friction stiffness to 6. That makes the car much more driving much more better. You can drive faster with the car, you can accelerate faster, and you can also steer through corners better without slipping away. So that's it, and there's only one thing that we can also set, but therefore I need to run the game. We have the center of mass of the car. So if I go inside the car, the controller script is now connected to the this car object, and we can go to the scene view, and you can now see there is a gizmo drawn, this red sphere over here, and that's the center of mass that's currently being used. You can see over here that the rigid body has an automatic center of mass. It's based on the dimensions of the collider. So, but it's in the center of the car, and that's not very handy. It's better to have the center of mass a bit lower, so the car is more stable. and it doesn't flip over that easily. So if we make this not automatic but set it ourselves, we can determine a good position for the center of mass, and I would say somewhere over here. Would be okay. So a bit under the car makes the car much more stable. Yeah, you see that the car is now much more stable. You can steer, and if you drive fast and push the brakes, you will see that the car moves a little bit to the side. I did that on purpose, so you can make the car even spin. It's not working very well now, but if I increase the spin strength a bit, you'll see that if we brake, the car actually starts to spin, and you can use that to quickly make a turn, for example. If you want to make a 180 degrees turn, you can do it like this. Now we will add the optional features to make the car look even more beautiful. First, you can create smoke. As you can see, the car controller script has a property called smoke. I've added a smoke particle effect to that. And we can add that to this car as well. What you then need to do is only define the smoke position. So let's do that now. Go to the car. And add a game object. Let's call it smoke position. And put it in the proper place. I would say we see the exhaust over here, so the smoke is probably coming from the exhaust. Modern cars don't have that much smoke anymore, but it's still nice to have this effect. And now we can refer to that position in the car's script of this car. And then we can also add sounds. Therefore we're gonna add another game object to our car. Let's call this sound, and inside that object let's make an object called sound brake, and copy that, call it sound engine, and we assign some sounds to those game objects. I have some car sounds over here, and this one we want to play looping. We don't want to play it on awake. And for the brake sound, I've got a brake over here. We don't want to play it on awake, and we don't want to play it looping, and we want to make it a 3D sound, so put this all the way to 3D. Same goes for engine. So when you have only your own car, it's not that important to make a 3D sound. You can just play the sound, because you will always be close to your own car that you control. But if you have other cars and you also use them, you want to have the sound in the proper position that the car really is in. I will show you a bit what's the difference and that this is more realistic. But now we need to have the sound on the car location itself. So we need to have the sound object as a child of the car itself. And we need to make sure that these positions are all reset. So also this position reset. So now the position of the sound is really the position of the parent. So this position, and that's good. That's where the car is at. And now we can refer to those sounds in the car script again. And finally, we can also add a driver. You can see there's nobody inside the car at the moment. If you play a game and you always have the camera like this, it's not that important. But if you have a game like Grand Theft Auto and you can enter a car and you can also watch it from this side, then you need to see if there's somebody inside or not. So I have some characters over here. I've downloaded them from Miximo. And I'm going to add this guy over here and create an animator for it. I've already have an animator controller over here, and it's called Car Driver Animator. And it's very simple animator. It just has a base layer with one animation. And this is animation of a person sitting in a car. So we can now rename this to driver and put it inside the car. So it moves along with the car. And now you just need to put it in the right position. So the driver should be somewhere over here. He's still not in the sitting position. That's only when I will run the game, and then I can position him even better. And we can, because this guy is quite big, what you can do is disable the feet, for example. You can just disable them so they don't display, otherwise they might stick to the bottom of the car. And now we can also add a reference to this driver over here. And by default we want to make him disabled, so there's nobody inside. Now as soon as this guy moves to the car and he decides to enter the car, this object will be enabled, and this character will be disabled, and you will continue with a car instead of a character. Okay, so if you now sit in the car, you can see the person sitting inside. You can also see the smoke behind the car, and you can hear the sounds. And if you, for example, exit the car while driving, you will note that the sound will decrease the volume when you get more far away from the car. So that happens because of the 3D sound. If you don't use the 3D sound, the sound will just stay the same, and that will not be realistic. While running the game, we can position the driver a bit better. And then we can store these values. If you have a different car model and you start driving and it looks something like this, the wheels are not properly orientated, and there is an extra property in the car script that you can use to change the orientation. So then you need to change this value maybe to 90 or minus 90. But these cars, these wheels are properly orientated, so I can keep all these values to 0. One more important thing to beware of, that if you take a look at the root object where you put the rigid body, that this arrow of the z-axis is pointing in the forward direction of the car. If you take a look at this car, for example, the red arrow is pointing forward and not this arrow. So this car is not orientated well, and if you would drive with it, it would probably do something like this when you drive forward, because this mesh is just rotated differently. And the physics engine determines all the movements of the car, but the display itself is just drawn like this, because the physics engine assumes that you have the car drawn with the Z position to the front. So if that is the case, what you need to do is add a new object. It's probably best to use first a cube over here and put this as a parent to your car. So this cube now actually represents the car, and then you can orientate this child with all the other real car visual elements properly. So you can now rotate this if it should be rotated like this, and then you put every thing over here, so the rigid body and the collider and the car script. So it's all moves like this, and then you can just put this everything with the proper rotation. Now of course this is the proper rotation, just 0, but it could be that you need to rotate it like this or like this to make it have the good rotation. Finally, let's take a look at the scripting to see how this all works. We have this player object. It has a third-person controller, but it also has a car controller, so he can control cars. And as soon as you get near a car, we will see this hint that you can press the F key to enter a vehicle. Because we just check for colliders in his area of the player, and if it has a car script, you can enter the car. And then if you press the F key to enter the car, you will see that we disable some parts of the some elements of the player, like the third-person controller, because at that moment the game is controlled by just the car controller and not by the person controller. We also set some properties on the controller script, like a reference to the car that we are currently using. We use the rigid body that we've set in the car script, so you can quickly access the rigid body. It's an important object to use in the car controller. We also set quick access to the wheel colliders. We do some setup. We start playing the engine sound, but it can be a volume of 0 in the beginning, because we have a speed of 0. Let's quickly run through all this code of the car controller, because it's the main thing that you will use for your game. So we have a reference to the camera. We have also a text to show the speed. We have the material of the rear light, which we will change some properties of to show the light of the brakes. Something for the smoke effect, it's not that important. We have the Cinemachine camera attached. We also have the wheel colliders. We have some properties like if the car is braking or if it's in the air. It's important to know that, to use that in physics. Here we set up the car with the properties. And then in the fixed update, we will use fixed update instead of update because we are using physics. And physics should be put in fixed update. By the way, to have a good response, you can change the settings over here of the project. The time, you can set it, the fixed timestamp to 10 milliseconds instead of the usual 20 milliseconds. This gives a better response and helps increase the accuracy of your car controller. So we do some stuff like handling the motor, applying the downforce. It all speaks for itself. So this is the spin torque, for example, that we use to make the car spin when you hit the brakes when you're driving very fast. We have this optional traction control where you can get more control over the steering. This is the engine sound. We also change the pitch, but especially the volume of the sound is important. We apply the downforce to make the car more stable. We determine if the car is moving forward over here. We limit its maximum speed to the maximum speed that's being set. That's optional. We apply deceleration. When you don't press the forward key anymore, the car will not brake, but it will decelerate. So slow down over time. Like in reality when you don't press the gas anymore on the car. Here we apply the brakes and you can see that property that's being set to change the light from a brake light to a backlight and vice versa. Here we set up the wheel colliders, all four wheel colliders based on some properties. So you can set these properties in the car script and they will be used for all four wheel colliders. Here are the gizmos that are drawn to show where the center of the mass of the rigid body is. It's very important to know that to have a stable car. This is just to create the smoke effect. Here we're handling the motor, and the way the car moves is just by applying motor torque to the rear wheels of the car. And if we have four-wheel drive, we can use the front wheels as well. And this makes the car move. So this is actually the code that makes the car move. Over here we have the steering. We create a steer angle on the front wheel colliders. And over here we update the visual wheels. It's actually done over here. We get the pose of the wheel from the collider and we then just rotate the wheel transform, the visual wheel, to that same pose. And possibly we will use the wheel orientation if the wheels are not properly orientated to give it an extra, for example 90 degrees rotation to make them properly orientated. And over here we will check if the car is landed or not. In the late update we will update the camera, and the camera will just rotate around the car if we rotate with the mouse. That concludes the tutorial. This is all you need for a basic car game. There are still lots of improvements you can make on the car handling. Just ask if you need anything else. For now, thanks for watching and hope to see you again soon.